Hi everyone, we're Ella and Mallory, and we're going to be presenting on beaked whale detection techniques. Beaked whales are fully aquatic marine mammals and are visually detectable when surfacing to breathe. They're medium sized, about 15 to 23 feet and 4,000 to 6,000 pounds. They're found in all oceans and have very cryptic behavior and are not well understood. They dive deep to forage, and much about these whales remain a mystery.
Methods for estimating populations of beaked whales is dependent on their detection. Beaked whales are elusive and deep living whales that only surface for short durations. So, our problem with beaked whale research is one of efficient and accurate detection.
The methods for detection that we'll be discussing throughout the presentation include acoustic data, fecal samples, and eDNA.
Comparing it all to visual detection surveys, where you visually identify and detect whales from boats. It is effective for other whale species, but we believe it's ineffective for beaked whales because they are deep diving and only surface for short periods of time. They like to avoid boats and people.
The first method we're discussing is acoustic data. Acoustic data is the use of underwater microphones in different forms to track acoustic sounds from whale echolocation. The pros of this method is that you have the potential to detect submerged whales without seeing them, making observation potential greater. With technology advances, it makes it easier and more efficient to identify different whale species. It's also cost effective compared to visual surveys since you don't have to employ people to watch for the whales. And it's not dependent on sighting conditions. Visual surveys are ineffective if the water conditions are harsh, while acoustic detectors are not impacted by these conditions. The cons, however, is that beaked whale sounds are not well understood, making it hard for identification through the acoustic detector softwares. Beaked whale echolocation is also at a very high frequency that is not recognized on shelf products. This causes researchers to have to buy more specialized and expensive detectors. It's also shown to be effective to only a distance of about 700 meters, and beaked whales dive much deeper than this.
Our next method is fecal samples. Whale fecal matter is detected using scent trained dogs that help guide the research boats. The samples are collected through fecal follows, like surface collection with a scoop, net, or divers. With this sample, you then analyze the DNA to determine the whale species. As for pros, it's a passive method, meaning there's no capture necessary, leading to less stress for the animal. If this is more than just a presence data, it gives us insight into the whale's diet, hormone levels, toxin exposure, and overall well being, compared to visual surveys that only look at external appearance. Collection using dogs is the most effective way compared to collecting samples opportunistically. The cons for this include difficulty locating fecal samples even when using dogs, low sampling rates, the fact that we cannot confirm species while in the field, DNA degrades over time. It is dependent on sighting conditions like rough waters that make it difficult to detect and sample, and dogs' ability varies.
The last method we're going to discuss is environmental DNA, or eDNA. eDNA is determining species presence based on analyzing DNA extracted from the environment, or in this case, the water. This allows you to get presence data for all of the species in the area. The technology for this technique is displayed in the first photo. The pros for this method is that it is also a passive method, and water samples are taken from the surface with no whale detection necessary. It's efficient, and lots of samples can be easily collected from different locations, and technology is rapidly improving, leading this method to becoming more and more efficient out of all sampling methods. As I stated earlier, visually spotting whales is not required. The cons for this method is that samples must be analyzed in a lab, which takes people, time, and money. Sample quality declines as time increases. DNA degrades, and if the beaked whale has not surfaced in a while, they might not show up on the DNA sample. There's also the threat of inconsistencies with identification, with false positives and false negatives.
Although it has its drawbacks, this is our recommended method. It is the most efficient and accurate out of the methods presented for non visual detection. With technology advances, it has the most potential for growth and a decrease in inconsistencies.
We would like to take a moment to recognize our references that helped us formulate this research project.
And again, my name is Mallory.
And I'm Ella.
Thank you.
And if you have any questions, please post them in the comment section below.